Okay, welcome back to class today. We're going to continue our dive into safety with a tool that you have probably seen quite a bit if you drive on the highway. My goal or objective for today is that you will be able to read and interpret the fire safety diamond. And saying that, let's dive into this video. The fire safety diamond or safety square was adopted in 1960 by the National Fire Protection Association. Its original goal was to provide emergency personnel the ability to quickly identify risks posed by hazardous materials. This allowed them to be able to quickly dispose and safely clean up chemical spills. This diamond can be broken down into four parts. The top portion, which includes some sort of red within the top section, is the flammability risk. The left portion usually is blue and gives the gauge of health threat that a specific chemical may have. The far right portion usually is yellow and assesses the reactivity risk of a compound. Then the bottom of the fire diamond usually gives a special note and is usually left white. Each of these colored quadrants have a numerical value 0 to 4, which determines the specific degree of precaution needed. Usually 0 being nothing to worry about, while 4 means handle with extreme caution. We're going to go farther in depth with these quadrants and their specifications now. So let's start off with our flammability quadrant. Once again, this is the top section, usually has some red in it, and whether it be on the number or the background, red is present. If there is a 0 in the flammability quadrant, then the material does not burn under typical fire conditions. This usually means it is non-combustible material, such as concrete, stone, or sand. A 1 in this quadrant means the substance in the labeled container needs considerable preheating under ambient temperatures before ignition or combustion can occur. This also includes some finely defined suspended solids that do not require heating before ignition can occur. Typically, our flash point or point of ignition for these substances is 200 degrees Fahrenheit, so not very likely. Continuing with our trend, a 2 in this quadrant means the substance can be ignited by moderate heating or exposing it to relatively high ambient temperature. Flash point for this is between 100 degrees Fahrenheit and 200 degrees Fahrenheit. A good example of this would be our diesel fuel, sulfur, and even paper. A 3 in the flammability quadrant would contain substances that can ignite under all ambient temperatures and conditions. These are such as gasoline or acetone. Liquids that have a flash point below 73 degrees Fahrenheit and a boiling point above 100 degrees Fahrenheit. Finally, a 4 in the flammability quadrant means substances will rapidly or completely vaporize at normal atmospheric pressure and temperature, or is readily dispersed in the air and can be burned easily. A flash point for these substances is below 73 degrees Fahrenheit. Think of a propane tank. It can be dispersed into the air quickly and can easily catch on fire, thus spreading a flame out opposed to isolating it. Now we can move on to our health quadrant. This is the far left. A 0 poses no health hazard and no precaution is needed when handling these substances. Think of something like wood. A 1 would create a mild irritation or minor residue injury if exposed to a substance. Think of acetone or nail polish remover. A 2 means that intense or continual but not chronic exposure could cause temporary incapacitation or possible residual injury. Think of chloroform. If you inhale a high concentration of it, you will pass out. Trust me, I know. A 3 in the quadrant would mean that short exposure could cause serious temporary or moderate residual injury. Think of sulfuric acid. It can severely burn your skin, and your skin will repair itself, but it may take a while to happen. Finally, a 4 in the health quadrant means very short exposure could cause death or major residual injury. For example, this would be hydrofluoric acid. Look what it does to a chicken leg. Our next quadrant is the far right quadrant. This is the reactivity quadrant. This quadrant is dedicated to how stable a substance is. The lower the number, the more stable the substance is. This means a 0 on the activity quadrant would indicate that the substance normally is stable under fire exposure and it will not react with water. An example of this would be helium. A 1 in the quadrant would indicate that the substance is normally stable but it can become unstable at an elevated temperature or pressure. A 2 would indicate that the substance will undergo a violent chemical change at an elevated temperature or pressure. These substances can react violently with water and explode. An example of this would be our pure sodium. A 3 in the reactivity quadrant means that the substance is capable of detonating or has explosive decomposition, but requires a strong initiating source. An example of this is pure hydrogen peroxide or cesium. Finally, a 4 in this quadrant would indicate that the substance is readily capable of detonation or explosion, decomposition at a normal temperature or pressure. An example of this is tinitrotoluene, also known as TNT. It's dynamite. Okay, cheesy jokes aside. Our final section is the bottom special notes section. This section can contain symbols opposed to numbers. These signals tell us other pertinent information about the substance. This information can tell us how we are supposed to handle such a substance. So here's our first notice. If we see an OX in the bottom quadrant, that means the substance is an oxidizer and allows chemicals to burn without an air supply. This can once again be like your hydrogen peroxide. A W with a slash through it means it reacts violently with water, such as cesium. An SA means simple asphyxiant gas, such as helium, nitrogen, or a noble gas. COR means the substance is corrosive or a strong acid, such as sulfuric acid. Acid, or ALK, means the substance is an acid specifically. Bio means as a biohazard, such as a flu virus or rabies virus. POI means poison. RAD means radioactive. These are substances such as plutonium or cobalt-60. And finally, CRY means something that's cryogenically frozen. An example of this would be nitrogen. Okay, now you have a fairly good understanding of the safety diamond. Whether you see it on a truck as you drive down the highway or in your chemistry class, you will be able to quickly address the properties and threat level of a substance by using this safety diamond. In saying all that, keep up the good work in the classroom and see you next time.